Hello again, everyone. This is Amir McKean, electrical engineer, author, publisher, and founder of AIC Publications and the Black Stemporium podcast, your number one source for science, technology, engineering, and math. How to start your own publishing enterprise, building generational wealth, economic empowerment, all centered around the Black African American experience. Back again with another tutorial in the AIC Publications 10-minute engineering program, where we always try to demystify the math and simplify the science. Today's tutorial will be focused on voltage, the electromotive force. Now, from our previous lesson entitled Batteries, the Electron Pump, you learned to think of the electromotive force, or EMF, as a pump that moves electrons from beginning to the ending point. Well, the electromotive force, or EMF, that actually does this, the official term is called voltage, or a volt. And the unit is the volt that we measured in, and it's signified by the V. Now, the different voltage characteristics that are present, there are two types of voltage. We have DC, or direct current, and AC, or alternating current. Now, there's a couple of differences between the two. In DC, the current only flows in one direction. However, in AC, the current may change directions. DC is typically used for storing power in battery operations and low level electronics. AC is often used for power transmission and distribution systems and high power applications. Here in the Black Stemporium podcast and the AIC Publications 10-minute engineering program, we will build our circuits using low level microelectronics that will work off of DC and AC. As of 2022, as you can see on the screen, there are 8 different voltage level classifications, and they are rated as such. They're rated by the amount of voltage that can be produced on each level. So the ELV is extra low voltage, LV is low voltage, medium voltage is MV, high voltage is HV, and extra high voltage EHV, and then you have ultra high voltage UHV. And you see the different characteristics there. You also have a rated classification. The rated classification means if you're powering your device off of a generating station, then the device that you're powering is going to be rated by the maximum capacity the generator is going to be able to generate. The voltage, which can be obtained from a generator or a battery, actually pumps the electrons to be used in our circuit. This performs similar to a water pump that you saw on the previous slide, a water pump that has to be primed at the handle several times in order for the water to flow. Now, the priming process in electronics, it takes place through the events that we previously described: heating the electrons, lighting the electrons, and as of lesson 3, you learned that causing a chemical reaction can classify as one of these events that take place in the priming process of that pump. Now, as stated in lesson 1, entitled Where Does Electricity Come From?, you learned that electricity can be transformed from one form to another, that energy, can be transformed from one form to another. So far, we've discussed electrical energy being formed from temperature changes, heat, and chemical energy. Now we can discuss forming electrical energy from mechanical energy. Now, focusing on the first rated voltage brings us to discuss generators. Now, a dynamo, or a basic generator, consists of a mechanical aperture, elemental metals, and physical electrical contacts. The basic premise or principle is that when the mechanical winding is turned at a particular speed, this moves the electrons in the elemental metals toward producing a voltage, which is then transmitted across the electrical contact. So this serves as the pump that does that pumping process we talked about. The item being powered will have continuous voltage as long as the winding is kept turning. An application of this could be connecting a light to the handlebars of a bicycle. Then the dynamo will then demonstrate the basic functions of a generator, but cannot be utilized when precision and continued power and reliability is required. The dynamo that we're talking about on the bicycle, the reason why it can't be utilized when you need precision power is because once you stop pedaling, the power goes away. And the amount of massive power that's needed for many applications just can't be generated using that. That's why it's called a dynamo or a low level type of generator. Now, when precision and regular power is required, there are both DC and AC generators. The overwhelming majority of generators used in any industry operate from generating an electromagnetic field, such as the generators that you see pictured here. As you can imagine, no person could turn the winding on something so massive indefinitely. So the generators used in all industries have been designed to accept an impulse function or simply a burst of energy that's produced from the electromagnetic field, energy outside of the generator in order to stimulate the turning of the mechanical gears. The electromagnetic field energy then keeps the rotation going until the generator is powered off. Now, the generator on the left is DC and the one on the right is AC. The final item to cover here is that which produces a voltage is called the power supply. Now, these are standalone units. They're plugged into the outlet and they can produce low level electronic level voltages, usually between 0 36 volts. Some can go higher, maybe 100 or a couple of 100 volts sometimes as well. Some applications will be even more so, but for our purposes, we're going to limit ourselves to the beginner level and we won't exceed 18 volts in the tutorial programs that we're creating for you. Now, the power supply can output AC or DC depending on the type. The voltages may be individually set in pairs, and many supplies come with short circuit protection. That means if someone were to turn the supply on and connect the negative terminal into the positive terminal directly without a circuit in between it, rather than destroying the power supply, it would simply shut it off and reset. In older power supplies where this feature was not included, engineers have to manually account for such an imbalance. Now, if you've enjoyed our content and want more of it, I need you to do 3 things to help us reach more of our audience. First, go to our website using the link you see on your screen and subscribe to the AIC Publications newsletter directly. If you do that, you'll get the following. You'll get weekly emails whenever we release tutorials, podcast episodes, new books, contest giveaways, and a whole lot more. If you do this, you'll also be able to get a free book. Doing this helps us become more independent of the platform that you're using or watching or listening to me on now. So that if this platform goes away because of a takeover or the business is sold, we can still reach you directly. We can still serve you and give you this beautiful content. Second, subscribe to the current platform that you are watching or listening to us right now. This will help more people on this platform be able to be brought into our direct pool that we're trying to create to be independent. Third, share our content with 3 of your friends, 3, using the hashtag AIC Publications and link to our website. Thanks in advance for helping us to demystify the math and simplify the science. Remember that we want all of our community members to attain the knowledge, innovate for success, and command your future. Till next time, all the best. Peace.